Hi, it's Jocelyn. This is Evan to Code Day 9. Alright, so we have our input. It's a bunch of long numbers, it looks like. Alright, smoke base then. Supposed to vanilla points, okay. All right, so we're going to enumerate these. We have y and then the line, and then for x character in line.chars also.enumerate, we're going to create a map. So what do they call this actually? A height map. Yeah, we're just going to call this a map. Is equal to hash map, and we're going to add to it. So so then we're going to insert yx c dot parse dot c dot, there's like digit, there we go, and it's base 10 dot unwrap. There we go. And now we should have, we have map of usize to I32, so that we can do negative numbers without worrying about it. I'm just going to call these I64s. And then we need to know the size of the map. So max y and max x, and then we'll say max y is equal to y and max x is equal to x, because we're just curious about the very last one. Okay, now for y in 0 up to max y, it's not, because it's not the number of lines, it's the number of the last lines, so that's why the equals is there. And now we just want to check whether it's the highest. So if map dot, actually we'll just say this point is equal to map at yx, and then we need to look at four corners, or the four adjacent points. So for dy dx in, we have a nice little array here, so above and below and left and right. For each of those, we're going to get the other point, which is map.get x plus dx, and then y, it's y plus dy, and then x plus dx. And if there's a value there, because it could be at the edge, and if you don't care, then we want to know if this point is bigger than the other point. So if other is greater than this point, or is actually, we're going to say it's not greater, then it's not a low point, and we can break. So if it's a low point, then we're going to use that to compute our scores. So the score, or the sum of the risk levels, is equal to 1 plus its height, which I guess is probably y. I'm going to use the example here, just so I don't embarrass myself too much. And that should equal 15 once this compiles. Okay, so, right. easier just to do this. We can improve that later. Okay, other. There we go. Right, and we need to return it, and map needs to be mutable. That was just a quick fix, so I can't type mute that fast. And it says the answer is 15, not 10, so we're making some kind of mistake here. Diagonal locations do not count as adjacent, so let's print which ones are low points. Oh, the height, not the y. Okay, 1 plus, so we can say just p. Oops. Yeah, that's fine. It can be either two. Okay, and that passes. So now, hopefully, this will give us our answer to part 1. 524. That seems pretty low. I'm going to post anyway. It's right. All right, let's go to part 2. So next we need to find the largest basins. Basin is all locations that eventually flow downward to a single low point. Every low point has a basin, although some basins are very small. Okay. So if it's 9, it can't be in a basin. Otherwise, we're just like kind of doing a flood fill out from a point to points that, we're doing a flood fill from a point to all points that are not 9 and are larger. So yeah, so a lot of this is just the same as part A. But now, in addition to a map, we're going to have a basin map, which is similar to map in that it's the same type. So it's a hash map. I'm just going to type this here so I don't get confused. I64, I64 to yeah, U32 is fine. And then I'm also going to have a variable called last basin, or current basin, I guess. Which starts equal to 0, and when we're finished filling a basin, then we'll go up. Then we will find the next basin, or like increment that, and the next basin we find will have that number. Okay, so let's see. It says here it gives us a useful hint, which is that. All the basins, yeah, every low point has a basin, although some basins are very small. And I think that we can just start our basin fills, just like at the low points. So this code still all applies just fine, except we're going to make a list of them. So low points is equal to ec.new, and then we're going to say here low point, low points dot push, and that's just going to be yx. Okay, now we're going to do a flood fill. Let's see if I can remember kind of how to do this. So for point in low points, we're going to start at the, let's see, places to fill, or yeah, to fill is just going to be a vec that starts with that point. Then, well, let sum to fill equals, well, I'm just going to say again, point equals, yeah, to fill dot pop. Then we're going to see which points around it are bigger, but not 9. So this point is equal to, there we go, this would be height. And then it's the exact same thing as this. We check if it exists. And if other is greater than p, but also if other is not 9, then it's going to be as part of the same flood fill. I actually realize we don't need current basin here. We can just say low points dot enumerate against the into iter dot enumerate. Then we have basin point, and then we're going to say to fill dot push this new point, so that would just be other. And over here at this point, we're going to say what is our variable name for the basins? Basins dot insert to fill with the basin number, and we just want to assert that before is none, because if it's not, that means that basins are overlapping. So now we want the 3 largest basins. That's kind of annoying. First of all, I just want to make sure that we have that we got this at least kind of right. So I'm going to just print the basins for the example and see how that works out. So same example as before, I think. And this is just example 2. And eventually want to assert that this example gives us 1134. Okay, that should actually be point. We're calling basins U size, that's fine, not just the basin number. P is not. Oh yeah, we're calling this height over here. And we're calling this just y plus dy, x plus dx. Oh, and we need to make sure that we haven't visited here yet. So also basins dot contains key. And that would be again y plus dy, x plus dx. And I sorry I'm shooting myself in the foot by typing that so many times, but hopefully it's okay. And y over here is actually just point.0, and x is just, okay, yeah, so I give up. Something like that. Okay, and it looks like that has no problems. Assertion failed before is none. Okay, I'm a little bit worried about that because we have this basins.contains key. Maybe we're inserting something twice. None is returned. Well, in this case, it probably shouldn't finish. Okay. So it looks like here it is. Okay, I'm going to investigate that later, but for now it does look like we're creating 3 basins. And so now we need the basins with the 3 biggest sizes. So I'm sure there's a better way to do this, but here we go. So basins, basin sizes equals, this is going to be another hash map, and for basin in basins, we're going to, and that's, we don't actually care about the points, so that can be values. That should be just like basin number. So basin sizes dot entry at basin num, or default, which is 0, is going to be incremented by 1. And now we need the largest, the second largest, and the third largest. So we're going to say basin sizes. I don't like that U size there. Dot, and then into iter dot map. This is going to, so right now this is from the basin number to the count. We're going to, actually no, we're just going to, I bet there's a, do hash maps have like a sort thing? No, it's fine. We're just gonna collect this into a vec, because I think we can just sort a vec. Does that compile? And then if so, then basin sizes dot sort by, and we have a comparator, so the basin number and then the count, and we're just sorting it by the count. And let's see what that gives us here. Just want to make sure this is right, and if it's right, then we can just multiply the first 3. Sort by takes self and then a compare function. Oh, we probably do want sort by key. Okay, because that's if you want to actually compare 2, I guess. What is count supposed to be? I guess it doesn't know. U32, I guess. Okay, let's give this an explicit type. Hash map usize U32. And then that has an explicit size. So this should just work because the sort by key should just take one element, right? I guess it doesn't want to be destructured, so okay. So that's 9 times 14 times 9. Just to make this a little bit easier, and then we're going to return basin sizes 0, and then the size is what we're interested in, times, oh my goodness, times that. And we could do a for loop if we wanted to, that's fine too. We could probably be clever. We could use reduce. I think it's easier just to do this. And now we have example 2 passing, so we should be able to see if part B works. All right, that's a nice big number. And let's submit it. We got it right. All right, thank you so much for watching, and I will see you tomorrow.